We're all living through the AI revolution, right? But what's the actual engine driving it all? Well, it's not just software. It's a piece of hardware that, honestly, most of us never even think about, the all-optical network. So in this explainer, we're going to pull back the curtain and see how pure light is literally becoming the nervous system for our intelligent future.
But to really get where this is all going, we have to start with a question. What is AI's biggest weakness? Now, we could talk about things like bias or how it's changing the job market. But its most immediate weakness might be something way more basic: the actual physical infrastructure it all runs on. And this right here shows you the problem perfectly. Thanks to open source models, the cost of running AI, what we call inference, has just plummeted. We're talking down to 1% of what it used to be. Now, that's amazing for making AI accessible to everyone, but it also means demand is just exploding. Everybody wants to use AI, and that's creating this unbelievable traffic jam on the digital highways that have to carry all that data.
And that, right there, brings us to AI's hidden bottleneck. The very networks that are supposed to be supporting this AI boom are actually struggling to keep up. They're becoming a massive speed bump for progress.
Think of it this way. Imagine a city that was designed for horse-drawn carriages, and suddenly it's flooded with supercars. It's total gridlock. Our legacy networks, with their old copper wires and traditional switches, just weren't built for the amount of data AI needs. I mean, get this. To train a new AI model, you might need to update a computing cluster every couple of weeks. But rebuilding the old-school network to actually support that update? That can take a full week. It's a massive, progress-killing traffic jam. And when you dig in, the problem gets really specific. Just look at this breakdown of what causes network faults in data centers. A full 50%. Half of all problems trace back to just one component, those little optical modules you have to plug into traditional switches. That is a huge single point of failure, and it's exactly the problem that all optical technology is designed to get rid of. So if the old roads can't handle the traffic, you don't just add more lanes, right? You build a completely new kind of highway. And that is the all-optical answer. It's a fundamental shift in how we build our digital world. There's this great phrase that really sums up this whole evolution perfectly. 3 ins, 3 outs. It's a super simple, kind of catchy way to understand the core technology swaps that are happening as we speak.
So let's break that down real quick. The first one is the most obvious. Fiber in, copper out. We're swapping out slow electrical copper wires for cables that transmit pure light at, well, the speed of light. Second, fgOTN in, SDH out. That sounds technical, but it just means we're moving to a new, super efficient standard for industrial networks that replaces clunky older tech. And finally, optical sensing in, hard work out. Now this is where it gets really clever. The fiber cable itself becomes a sensor, so you don't need people doing manual, labor-intensive inspections anymore. Okay, now let's see how this all clicks together in the most important place of all, those massive data centers where AI models are actually born and trained. This section is all about boosting that computing core. Get ready for this, because this number is absolutely staggering. When you're training a high-performance AI, you have thousands of processors that have to work in perfect sync. In that environment, even a tiny, minuscule 0.1% loss of data packets can slash your total computing power by 50%. Half of it, just gone. It's an incredibly delicate process that needs a perfect, totally lossless connection.
And you can really see the difference here, side by side. We're looking at what's called Data Center Interconnect, or DCI, basically the massive pipes connecting different data centers. A traditional one is prone to that packet loss we just talked about. But in all-optical, lossless DCI, we're talking 0 packet loss. It can even survive someone accidentally cutting the fiber cable without dropping a single bit of data. That means AI training efficiency is totally maximized. And inside the data center itself, the hardware is just as game-changing. These new all-optical switches, like the DCO-XC, completely get rid of those failure-prone optical modules we saw earlier, which slashes fault rates. And here's the best part. Because they're just switching pure light, they don't care how fast the data is. They can handle today's 400G speeds, tomorrow's 1.6T, and whatever comes next without you ever needing to rip and replace them. Okay, so we've supercharged the data center. That's awesome. But the real point of all this is to get AI out into the real world, right? So let's look at how these same optical technologies are bringing AI to all kinds of industries at the edge. Take our electric grids, for example. They're getting way smarter, which is great, but that means a tenfold increase in data flooding in from thousands of sensors and devices. The old network tech just can't handle it. But that new fgOTN standard we mentioned, it can. And that enables real-time AI to do things like intelligent grid checks, which makes our power supply way more reliable.
Or think about a hospital campus or a university. They want to run their own AI models on-site, to keep sensitive data private. But things like AI-assisted surgery or research demand over 10 gigabits per second of bandwidth. Fiber to the office, or FTO, is what delivers that kind of speed, bringing powerful AI right into the classroom and the operating room.
And this is one of the coolest applications yet. Remember how the fiber itself can be a sensor? Well, Huawei's OVLS solution uses this for things like pipeline security. It is 10 times more accurate than the old ways of doing things, it needs zero power out at the sensing point, and it's already helped companies like PipeChina prevent over 100 potential disasters like theft or damage. It's pretty incredible stuff.
So, as we start to wrap this up, the big picture becomes really clear. The future of AI isn't just being written in lines of code, it's quite literally being woven from strands of glass.
If you remember just one thing from all this, let it be this simple, powerful idea. The super fast, super reliable connectivity that fiber gives us isn't just a nice-to-have for AI. It's absolutely essential. Put simply, no fiber, no AI.
And that leaves us with one last big idea to think about. We've seen how fiber can be used for sensing, for feeling the tiny vibrations along a pipeline. So if this gigantic optical network is truly becoming AI's new nervous system, what else will it eventually learn to feel? What new senses are we about to give to our intelligent world?